purpose of this presentation is to take you on a journey of discovery of science. A considerable amount of this work is original, and what it is concerned with is a doctoral PhD doctoral research which began in the early 1970s and finished with the award of that PhD in 1978. None of this work has been published so far. I was in doubt about the interpretation of some of the pictures which you'll see. So partly because of negligence and partly because of waiting for science to catch up, I have delayed this. Now this whole project started with locomotory disturbances in pigs in Brisbane, Queensland, Australia. As a diagnostic pathologist, I was faced with this problem of trying to work out the etiology of this particular disease. There are many causes of a disease, but the etiology is the primary cause. And it does not necessarily mean that that is the total manifestation of the clinical disease. What it means is that without that primary cause, the disease would not exist at all. Secondary causes and then tertiary causes. They're very important because they can modify the clinical manifestation of the disease. This is of great importance, and I will allude to this during this presentation, which was my PhD project, and then the conceptualization of that only in the last few years into something which really is presented as new paradigm shifts in this disease and other related diseases. This first part that I'm presenting is epidemiology and the notion of causation. After that, I will focus on neuropathogenesis and causation and the interaction of the host with the pathogen. Now, epidemiology and neuropathogenesis are intertwined in many ways. What it began with was a focal source of disease in one farm. By inquiry in the district and the like, it was found that this was a point source. And I will talk to you about the predisposing causes which, in my view, led to the clinical manifestation of this disease. Now, it must be remembered that this is the first isolation of this virus in Australia. Now, this particular disease is caused by a virus, porcine teschovirus 1. Up until 2014, the virus was classified as porcine teschovirus 1. At that time, it was changed to teschovirus A. This is the first isolation in the early 1970s, and this is the original first publication of that isolation. The isolation of this virus created a dilemma when I went into further research on this, because what I found was a virus which is supposed to be exotic to this country, exotic in the sense that it the exotic part, the exotic section called Tessin disease, was a disease with fairly high mortality and high morbidity, whereas this disease which I'll present to you, is of much lesser mortality, but still fairly high morbidity rates. But then we get into the dilemma later on when I find out that this disease is widespread throughout the whole of Australia. And that's the epidemiology part of it, where I found that it was endemic. So the question comes, are we faced with two strains of a virus like is present in the current literature? It's present in the current literature and has been for years that there are two strains. What I will be discovering, and you'll discover as we go along, is that there's really only one strain. So that's why I say we've got exotic and endemic situations. So what we're doing here is I'll first do a clinical examination, and then I'll go on to look at the sampling from that, the sampling to attempt to isolate and characterise this virus for the first time in Australia. In speaking about this as an original isolation, it is quite interesting that this has been the only isolation. This virus was first isolated in 1970, and there's no other report of the isolation of porcine tesco virus 1 in Australia. During the course of this natural outbreak, I took the brains of the affected animals, and I mapped the lesions out both qualitatively and quantitatively using knowledge of neuroanatomy. And so mapping these lesions out, I was able to observe, and viewers will be able to observe, the pattern of disease. Unfortunately, with nervous diseases of man and animals, the pattern of the disease has not been made or done. So this is an original contribution which will form the guidelines for future work on nervous diseases of man, such as Alzheimer's disease and other diseases, in which the etiology, the pathogenesis, treatment, control and prevention still remains completely unknown. This is most unfortunate for Alzheimer's disease, because Alzheimer was discovered in 1907 by Alzheimer, and research is no further advanced than it was in 1907. How many years is that? And the only thing that research can offer us now is things are going to get worse rather than better. As the population ages, the disease is going to increase. Now, a major reason for this stultification or stagnation of research is because of the over-fascination with amyloid. Amyloid is a glycoprotein, beta-pleated proteins. It's a secondary product. It's a secondary cause. Certainly, it does cause serious effects upon the neurons, but it remains a secondary cause. So this over-fascination with amyloid in Alzheimer's disease has caused things to happen like attempts to produce immunoglobulins against amyloid, which is quite ridiculous because the original or the primary etiological agent has never been found. So this is what I mean about causation. This is what I mean about causation. The primary cause, the etiology. And that is why, because the guidelines are not there to be seen from this topographical mapping, which I'll show you. Now, before I proceeded with the what topographical mapping, I investigated this disease using standard histopathology techniques of hematoxylin and eosin and special stains. Out of that histopathology, I made some new discoveries, and one of them is the Watt cell nodule, which I believe is of fundamental and great importance in the study of neuropathogenesis of viruses and possibly many other agents. After that, I proceeded to the experimental part of the neuropathogenesis, and I began by inoculating the animals through various routes to see how the virus got to where it did, and to see whether it got anywhere else as well. After looking at the various routes, I then went on to a rather large experiment in which I compared virus only with virus plus immunosuppressed pigs. The whole exercise from this rather large experiment of virus versus virus plus cyclophosphamide was to examine the pattern of the disease. Unfortunately, the pattern of the disease has been overlooked for many, many diseases of humans and of animals, but particularly humans, and in the case of Alzheimer's disease. In Alzheimer's disease, the pattern of the disease is completely unknown. In Alzheimer's disease, we don't even know for sure whether it's a transmissible disease. One experiment's been done. In over 100 years, one attempt has been made and published to see whether it's a transmissible disease or not. This is most unfortunate. So, what one is doing with this study between the virus and the virus plus cyclophosphamide is to look at two things: the pattern of the disease, the sequential pattern. It's a study of disease where I looked at it from day 6 onwards and followed the pattern of the disease, virus only and virus with cyclophosphamide. It had two objectives: to study the pattern of the disease, and the other objective was to revisit the 2-strain current dogma that's in the literature right now, that there are 2 strains of Teschen disease virus, the virulent strain and the mild strain. The mild strain is supposed to exist, or suggested it exists here. In other countries they talk about it being there, but they refuse to talk about the virulent strain. Now, what I'll show, by the use of immunosuppressives, that there is only one virus. The virus of porcine tissue virus 1 is a stable virus. It's a genome that's quite stable, and there's very little genetic drift in it. It's generally accepted that this is the case. And so for years, people have been trying to work out how it is that you get a virulent form and a mild form. In the past, some 30 or more years ago, the virulent strain and the mild strain were injected into experimental pigs, and there was no significant difference between them. Now, one could attempt to justify that by saying, oh, the the virulent one was weakened by passage. Okay, that's a possibility. But the other possibility is that there is a natural immunosuppressive in those animals at the time that the Teschen virus comes in, and so because of that immunosuppression, there is an elaboration and spread of that virus throughout the central nervous system and peripheral nervous system that otherwise would not exist. It would seem that this virus alone produces rather milder forms like the Talfin form, and under the immunosuppression, under natural immunosuppression, there's a greater elaboration of the clinical manifestations.